set that white balance thing. All right, so here we go. So we write this. This is going to have some long names to it, but it's no big deal. Up here, we got a sulfur on the end. So what's in between is going to be this acyl group. And that's the acyl group that's going to go onto the citric acid cycle. So the way it gets bound here, this sulfur has that. To know. Just a methyl on there, so essentially it's just fast for you. That's a Schroeder diamond there. This is your CH3, this is your acyl group. This portion here, let's keep all this true to form here. This sulfur up here, this goes to a diamond, that goes to a diamond. These two are connected, so if you can, draw it that way, and then this actually comes this way down. Diamond, diamond, however you want to do it. And then what it has is double bonded O to a nitrogen. So if you wanted a little color coordination here, you do blue and green. It's green up there. Now this sulfur has an H on it. These guys are just a ring. So there's so much sulfur utilized in this one reaction just to get, I mean, the books just fly right over this, and this is the most important part. Sulfur's yellow. Double bonds here, right? The purple is a methyl up there. So this group is going to go up to this sulfur here. So the way they picture it is this little electron Now this electron density can go into the carbon, but over here it's actually the carbon that goes into the sulfur. So this one enzyme comes by over here, the dihydrolipoamide-transferase, and it gives a proton to the carbon up here, which is in an alcoholic form. So we're going to draw just the front portion of this. So here's the whole B1 coming across. We're just going to draw this part. So we need a nitrogen. Nitrogen is double bounded with carbon. And that carbon goes to a sulfur that's in the ring. This goes to the diamond over here. It's actually going to have a double bond on plus on it. So the little alien here is going to carry it that way. So what we got up here, the carbon is carrying the acyl group, which is going to be the diamonds. You draw two first, because there's just two carbons. If you want, it's a methyl, so you can color that in. This is an alcohol. And just an H. So what's actually going to happen is this H is going to get taken off. It's going to leave an electron. It's going to attack the sulfur. So that goes. See over here how it is? That carbon, we're going to color it black so we know which one's which. Let's see, let's color this in since we got it all here. This is vitamin BS1, we call it. BS1 has the sulfur. It's got the nitrogen. It's going to get a little plus charge, you got to remember. It's got 4 bonds on it. So, color in the diamonds. So the important part we're looking at is here. Lots of yellow for the double bonds, yellow for the sulfurs. This O. Proton goes, electron attacks the sulfur. Another enzyme actually attacks this sulfur over here. So this carbon loses that. Electron negativity goes for the sulfur. This gets a proton on it. So now you're over here. You got this sulfur with a proton. The double acyl group, as they called it, gets deprotonated. Becomes a ketone. So now with the ketone, acetyl-Coenzyme A's sulfur can come along, slap up into that carbon, and take it away as acetyl-Coenzyme A. And what you're going to be left with are 2 of these sulfurs with H's on them. So let's color these in. As we came across, the acyl group is now on our lipoic acid. That's why this is such an essential nutrient here. This is 2 sulfurs.